MassCenter offers a number of choices of the integrator. So it's worthwhile to spend some time figuring out what is the best selection and the historical perspective from where these integrators came from. There are two main classes of integrators. The first ones we'll talk about are the existing parameter integrators. So the older name in the GCMSD ChemStation, for example, was RTE or Genie. These were renamed General and Universal, and they act the same as before and offer a set of parameters I'll go through briefly. In addition, we've added recently a spectral summation integrator, which gives a special case to adding up the ions in that retention time region. The main focus in the last decade has been on parameterless integrators to put the smarts into the integrator, and that started with the MS-MS integrator, which was focused on the triple, and then proceeded to the Agile, and then a new version, Agile 2, which got smarter with the local baselines. So here's a list of the parameter integrators that we just mentioned: General, Universal, Spectral Summation, and the parameterless integrators mentioned. The integrator selection is made in the method editor. So if you go down to Advanced Task, you'll run into Integration Parameters Setup, and I'll show you details of that. Also note that in Batch at a Glance, you do have the ability to set the integrator parameters for a specific sample compound so that you can actually control its integration on a specific basis. That is showing you the same user interface that's presented over here in terms of the choices. So let's take a look at the parameter integrators. So here are the parameters for the general integrator. And you'll notice that there are knobs to control where the baseline starts. It's terribly important to set the threshold correctly so it triggers, and you'll notice baseline and where the baseline preferences in terms of how to draw the baseline are key here. Now note that this integrator works in terms of a derivative looking for changes to establish the beginning of a peak. So next, the universal integrator, which was built on the general integrator, and we have the threshold as we just talked about, area reject. Peak width now starts to enter into it, and we have powerful timed events. For example, we can say the peak width value has to be at a particular time seen in order to trigger that integration. And you can see from the set of choices how granular you can get in terms of turning on and off criteria for specific characteristics. Last, the spectral summation integrator, which is described elsewhere, so I'll be very brief. We call it the blobogram integrator, and it allows you to integrate an area which really doesn't have the shape of the peak by picking start and end integration areas with certain criteria of setting the baseline, even from the beginning of the chromatogram. Another set of parameter choices that are available in the integration setup are collected in the peak filter dialog. This allows you to reduce the number of integrated peaks that you're going to receive from that chromatogram, and you can threshold by area or height or percent area, percent height. You can even limit the number of peaks that are coming back from that chromatogram in terms of what's returned from the integrator. Now for a brief discussion of the parameterless integrators. The first integrator was the MS-MS integrator, which was designed for the LC triple signal characteristics. Works extremely well if the baseline is flat. A version was distributed for the GC triple, same case. Next came the Agile integrator, which was designed for more sophisticated signal characteristics, and Agile 2 improved the behavior on sloping baselines and does a local baseline smart approach. Now a word here, I've seen folks that have actually mixed up parameterless integrators with parameter integrators. It's difficult to beat a parameter approach if you know what's coming with the signal. So there are cases where the general and universal come in very handy to handle compounds which aren't well resolved. Thanks for your attention.